This is the shell method for question 1C. So the shell method says that the formula is 2 pi, the integral from a to b of the average radius times the height of the shell times dx. And this is our graph, and this is the representative rectangle of our shell. This is the area that we're finding. So what we want to find is the average radius of the shell. The radius would be this right here, and it gets smaller as the x goes up this function, as you can see. So the radius would be, since we're starting at 4, would be 4 minus the x value. So that will be 2 pi, and it's going from 0 to 2. So our bounds are 0 to 2. That is 4 minus x. And then the height of our shell, which is just the upper function, which is y equals x cubed. So it would be x cubed, and then all that multiplied by dx. And then you just solve the integral, which you distribute these, so that would become 4x to the third minus x to the fourth dx. And then that turns into 2 pi, and then when you take the integral of 4x to the third, the 4's cancel out, and it leaves you with x to the fourth, and minus, that's x to the fifth over 5. All evaluated at 2, or 0 and 2. And then you just apply the fundamental theorem of calculus, which is 2 pi. Plug in these numbers, it'll be 2 to the fourth minus 2 to the fifth over 5. And you don't have to add the zeros, because if you just plug 0 in, you just get 0. So, and this becomes 16 minus 32 over 5. Then you want to simplify the 16 into a fraction so it's easier to solve. That becomes 80 over 5 minus 32 over 5, which then becomes 48 over 5 times 2 pi, which leaves you with 96 pi over 5 as your final answer.